moving on to 6.4 complex fractions. So that's our topic. Complex fraction defined is a fraction on top of another fraction. So you're going to see fractions on top of fractions today. We're going to be able to simplify this down, though, from fractions on top of fractions to a single fraction. So the goal is to simplify to one fraction in the end. And that's by multiplying by the LCD, the lowest common denominator, which we've talked about in this unit. So if we take a look at the LCD, that's all of the denominators. So for this first example with just fractions, this half, this third, this fourth, and this fifth, I'm looking at all the bottoms. So the bottoms here are 2, 3, 4, and 5. So if we multiply those out, we got to figure out what's the first number that we would hit if we multiply it out. And I think with 2, it goes 2, 4, 6. This is 3, 6, 9, 4, 8, 12, 5, 10, 15. And if you keep going, I believe for all of those, it's not 30. I think it's going to be 60 we're going to get to for all of these numbers. And I think 60 is going to be the lowest number that they all have in common. So if we go 60 and we multiply, if we multiply the top, that's going to be our next step. Let me do a different color. So this top by 60, this top by 60, this top by 60, and that top by 60. Whenever you multiply the tops by the LCD, that will always clear out the smaller fractions. So the top left would be 60 times 1, and then divide by 2. So 60 divided by 2 would give me 30. There's a plus sign. 60 times 1 in the top right is 60 divided by 3, and then you're left with 60 divided by 3 is 20. The bottom, you have 60 times 1 is 60. 60 divided by 4 is 15. And then the bottom right is 60 times 1 is 60. Divided by 5 is 12. So from here, I can see that the fractions are now gone that are on top of fractions. Now we have a single fraction where I can simplify it. So I get 50 over 27. I look to see if I can simplify that fraction at all. I don't believe that there's a number that you can divide into 50 and 27, so that's your final answer. So that's the goal today, is to go from those big fractions on top of fractions with a plus or minus sign all the way down to one fraction at the end. This next one, we have a 2, a 3, and a 6. So if we multiply that out, that's 2, 4, 6. This is 3, 6, 9. This is 6, 12, 18. It looks like 6 is our first number we have in common with all of them. So that's my LCD I'm going to multiply by. So the top left, the top right, the bottom left, and the bottom right, I'm going to multiply all the numerators by that LCD. When I do that, I'm left with 12 on the top left, 6 times 2. Then 12 divided by 3 gives me 4. There's a minus sign. 5 times 6 is 30. 30 divided by 6 is 5. The bottom right is 6 times 1 is 6. Divided by 2, you get 3. And then the bottom right, 4 times 6 is 24. Divided by 3, you get 8. I can simplify that down to one single fraction now. 4 minus 5 is negative 1. And then 3 plus 8 is 11. So again, it went from fractions on top of fractions with plus and minus signs all the way down to just a single fraction. So that's the objective today, and that's going to be the steps. Now, it's not going to be as easy because we're not going to just give you numbers in the bottom, integers. We're sometimes going to slide in letters or your variables, and sometimes we'll even have binomials. So that's what we're going to see today. And tomorrow gets a little bit tougher. So here's the steps that you're going to go through. The first step, we're going to deal with the right side example. is just find the LCD. That's always our first step. So if we look for the lowest common denominator, I'm going to do my numbers first. I'm only looking at the bottoms. I have a 3 and a 2. So I think that 6 is my first number that they both have in common. So my LCD definitely has a 6. And then we've learned that you find the biggest variable and exponent in the bottom for each letter, and that's also part of your LCD. So the biggest number of r's is an r squared, and the biggest number of t's is a t squared. So those both get added on to your LCD. So that's step 1. Step 2 is what we did above. Multiply each numerator. So every top, see, didn't mean to do that. Back. Numerator by the LCD that we found from step 1. So I'll do that in a different color. I'll do that in red again. So we're going to multiply the top left by 6r squared t squared. Top right, 6r squared t squared. Bottom left, 6r squared t squared. Bottom right, 6r squared t squared. When we do these multiplications, the top left, you'd get 12 for your number, and then divide by 3, so you have a 4 left. And then your r squareds would cancel, so you're left with 4t squared. If you still get a fraction number left, you know that you did something wrong. Okay. Oh, I forgot to write step 3. That's what we're doing right now. After you multiply, you're going to simplify. So now that's what we're doing right now. 4 times 6 is 24 divided by 2. 24 divided by 2 is gives you 12. 1 r and 1 t will cancel from the top and bottom for the top right, so I'm left with RT. The bottom left, no numbers cancel, so I'm left with a 6 for sure. The r squareds cancel, so I'm left with t squared. There's a minus sign. And then the t squared's the only thing that cancels in the bottom right, so I'm left with minus 6r squared. Now it's a single fraction. Once you get it down to a single fraction, you factor the top and bottom. Especially if there's only binomials or trinomials left. Sometimes if it's single numbers, you just can skip to number 5, which is, again, just after you factor, you're going to simplify down one more time. So if we factor the top, I see a GCF of a 4 and a t. So the thing left would be a t plus 3r. And the bottom, I could pull out a 6. And I have t squared minus r squared. The bottom there is the difference of 2 squares, because I see 2 things I could take the square root of with a minus sign. So it'd be t minus r, t plus r. It's a minus sign. So can we cancel anything when we simplify here? I believe we can. The 4 and the 6 on the outside will simplify down to a 2/3. And then that's it. I don't see anything else that will cancel. So my final answer would be t times t plus 3r. On the bottom, I have a 3, and then I have a t minus r and a t plus r. That would be my answer. So that's how you deal with monomials with variables. Excuse me. Number 1 down here seems to be not so bad with your LCD, because the only thing I see in the bottom would be an x and a y. So that's what I'm going to multiply all the tops by, is an x, y on the top for all of these. When we do this, it should give us one single fraction after we multiply and simplify. So the x's will cancel here. I'm left with negative 8y in the top left. The y's will cancel here, and I'm left with plus 4x. The bottom, the x's cancel here. I'm left with 10y. The bottom right, the y's cancel. I'm left with minus 5x. I look to see if there's anything that I can factor. These are not in correct order alphabetically, so I'm going to put them in the correct order first, though. So now the x is first, the y second. So the top I could pull out a 4. The bottom I could pull out a -5. And it looks like we see the same binomial, which is nice. Those can cancel. So -4/5 is my final answer for that one. It's very nice when they simplify down to a simple fraction. And this is the last one we're going to do with just the monomials in the bottom, just the letters. So I look at all the bottoms. You always got to represent the biggest W and the biggest Z, because those are the ones on the bottoms. So it looks to me like a W squared and a Z to the first are the biggest that I see on the bottom. So that's what I'm going to multiply by each of these tops, is a W squared and a Z. Each top of this, W squared and a Z, W squared and a Z. So see what we get. W squared Z, everything cancels, it looks like. So I'm left with 4W. The bottom, 1Z cancels here, so I'm left with W squared. 1W canceled here, so I'm left with plus WZ. So in the end, the only thing I could factor, I can't do anything at the top, but I can pull out a W in the bottom. So the W's will cancel, and I'm left with 4 over W plus Z. And that'd be my answer for 2. All right, and then the tougher ones, maybe for some people, maybe not for others, are these binomial ones. For binomials, we said when we found the LCD earlier on in this chapter that you just represent each binomial that you see one time. So I see an m minus 5 and I see an m plus 6. Those are the two things I see on the tops, or on the bottoms. So now I'm going to multiply each top by those two binomials. So we get m minus 5 and m plus 6 in the top of each one of these. M minus 5, m plus 6, m minus 5, m plus 6. So the m minus 5's cancel here. I'm left with a 2, and then that's an m plus 6. Sorry, it's a little scratchy. The m plus 6's cancel here, so I'm left with a 4 and an m minus 5. If we multiply that whole thing out, we get 2m plus 12, 4m minus 20. Combine like terms, we have 6m minus 8 on the top. So that covers my whole top. My bottom, the m plus 6's cancel, so I'm left with 5m, or 5 times m minus 5. The m minus 5's cancel. I'm left with -1 and an m plus 6. So if we multiply this out, that's 5m minus 25 minus m minus 6. So that comes out to be 4m minus 31. All right, let me check my work. I think that looks pretty good. Try to factor the top. I could pull out a 2. The bottom, I can't pull anything out, so I got to leave it. So that'd be my answer. I would also accept this answer since there's nothing that actually canceled. Sorry, didn't mean to write through that. So both of those would probably be good ones. The factored one on the right is what you'll most likely see a lot of. All right, last one we're going to do together is number 4. Number 4, the only thing I see in the bottom is an x plus 4. So that's my LCD. So that's what I'm going to multiply by each top. And those x's have a 1 underneath, so I wrote a 1. So that means nothing is going to cancel on the left side here. You're just going to have to multiply because there's just a 1 on the bottom. So top left, you have an x. Oopsie. do that in the other color. You have an x and an x plus 4. Top right, the x plus 4's cancel, so you're just left with an x plus 6. So this turns into x squared plus 4x plus x plus 6. So that's x squared plus 5x plus 6. The bottom left, you have an x and an x plus 4. And then these x plus 4's cancel. You have a minus sign and then a 4x plus 4. So if you multiply and distribute, you get x squared plus 4x minus 4x minus 4. So that's x squared minus 4 in the end. So that's what you get in the bottom here. So let's see if anything factors. Are there any multiples of 6 that add to give you 5? I think that's 2 and 3. And in the bottom here, you can find the difference of two squares, 1 plus 1 minus of the square root of 4. So you get x plus 2. So your final answer would be x plus 3x minus 2. Those are the only two things that you didn't cancel. And remember, you can't cancel pieces of binomials with others, so you can't cancel those x's. So you got to leave it as two binomials on top of each other. And that's what we have for this day for 6.4 part 1. See you tomorrow.